Now we're going to move on from absolute value equations to absolute value inequalities. What we have to keep in mind is that when we have an inequality, we need to decide whether the two inequalities will be combined with an and or an or. So less is going to be and that goes for less than or equal to, and then greater than is going to be or. And I kind of remember great or than can help you remind it. So we have a less than in this problem, so we'll keep that in mind later. The first step is the same as with equations. You need to get it so that the absolute value is by itself, which for this problem is already done. Then we're going to determine our two inequalities. The first inequality just involves dropping the absolute value sign and writing what I had. So that would be x is less than or equal to 12. The second inequality, you're going to leave the x alone, but you're going to reverse your inequality, so make it a greater than or equal to, and change the sign of your what's your number on the right. So I'm going to have x is less than or equal to 12, and x is greater than or equal to negative 12. Since we started up here with a less than, that means I'm going to combine them with the and word. The next step would be to solve the compound inequality, which we've already done. I have already my x is less than or equal to 12, and x is greater than or equal to negative 12. We're also going to skip the substituting. You should be able to substitute and get the correct answer, but we will move on. So my two numbers I have from my inequalities are negative 12 and positive 12. Let's look back at our original. We have it equal to, so these are both going to be shaded in. So filled in circles. Okay, and then my shading, I need greater than or equal to negative 12, but still less than positive 12. And remember, one way you can remember is with compound inequalities, my and statement should end up being one piece, and my or statements, the graph should end up being two pieces. Number 2 is much the same, except for we have the greater than. So I don't have to worry about my first step because they already have the absolute value bars by themselves. My first inequality is the same one I start with, just without the absolute value bars. So x is greater than 5. For my second inequality, I leave my x, I reverse my symbol, and I change my sign to a negative 5. Since I started with a great or than, I need to combine these with or. If you start with greater than, you need to combine them with or. These inequalities already have your variable by themselves, so I'm not going to worry about solving them. And then my last step is to graph them. So x is greater than 5. So we have negative 5 and 5. Remind myself we have open circles at those. And then or is going to be two pieces, so I have less than negative 5 and greater than positive 5. Let's look at some where I need to be solving for the absolute value first. All right, so in example 3, I'm going to look for my absolute value. It's already by itself. So inequality 1 is going to be x plus 5 less than 9. It's what I started with, but without the absolute value bars. Inequality 2 is going to still stay x plus 5, but I'm going to switch it from a less than to a greater than, and I'm going to change the sign of the right side, so negative 9. I need to determine if these two inequalities should be joined by and or. I started with a less than, so that means I'm going to combine them with and. So now I need to actually solve these two inequalities. X plus 5 is less than 9, and x plus 5 is greater than negative 9. So minus 5, x is less than 4, and subtract 5, I get x is greater than negative 13. I could also write this together as negative 13 is less than x is less than 4, if you wanted to. Now I'm going to graph my solution. So my two numbers are negative 13 and 4. So I need to be greater than negative 13, so that's going to the right, and less than 4. Open circles because I don't have an equal to. My next example also has the absolute value already by itself, so I can skip the first step. Inequality 1 is just dropping the absolute value bars. So absolute value, bars are gone, negative 6x is greater than or equal to 60. Next one, I keep the left side the same, reverse your inequality, and change the sign of what is on the right side. Since I started with a great or than, I'm going to connect these with or. Now I need to solve those two inequalities. Negative 6x is greater than or equal to 60, or negative 6x is less than or equal to negative 60. So divide by negative 6. Remember, when you reverse an inequality, you divide by a negative, then you need to reverse your inequality. So less than or equal to negative 10, or divide by negative 6. When I divide by negative, my inequality needs to flip. Greater than or equal to positive 10. So my two numbers on the number line should be negative 10 and positive 10. We have an equal to, so they're both going to be filled in circles. My first inequality is x is less than or equal to negative 10 and greater than or equal to positive 10. For example 5 and 6, now we finally have to start getting our absolute value to be by itself. So I have negative 3 plus absolute value of x minus 2 is greater than 5. So before I write my new inequalities, I have to get rid of that 3 and add it to both sides. So I have absolute value of x minus 2 is greater than 8. Now I can write my two inequalities. The first one just involves dropping your absolute value, so x minus 2 is greater than 8. The second one keeps the left side the same. X minus 2 flips the inequality, less than changes your sign, negative 8. Since I started with a great or than, these are connected with or. Now it's time to solve the one-step inequalities. So x minus 2 is greater than 8, or x minus 2 is less than negative 8. So add 2, which gives me x is greater than 10, or add 2 again, x is less than negative 6. My last step is to graph that solution. So I need negative 6 and 10. They don't have the equal to, so those are going to be open circles. I need less than negative 6 or greater than positive 10. Remember, or should be 2 pieces in your graph, and should be 1. Next one, we kick it up a notch. So 9 absolute value of x minus 2 minus 10 is less than negative 73. You want to treat this like a normal two-step equation. You're kind of just circling the absolute value and trying to get it by itself. So my first step would be to add 10 to both sides. 9 absolute value of x minus 2 is less than negative 63. And then I would be dividing by 9 on both sides. So I get that the absolute value of x minus 2 is less than negative 7. So my first inequality, just drop the the absolute value bars. X minus 2 is less than negative 7. The next one, keep the x minus 2, flip your inequality, and change your sign. Since I started with a less than, I'm going to combine these with and. Now I need to solve those two inequalities. X minus 2 is less than negative 7, and x minus 2 is greater than 7. Now, I'm doing a whole lot of work, but we're going to realize something when we get to the end that we could have taken a shortcut. So add 2, x is less than negative 5, and add 2, x is greater than 9. Now, think about this for a second. Can x be less than negative 5 at the same time that it is greater than 9? And the answer is no. So there's really no solution for this one. And if you remember from the equation video before, it has to do with this answer right here from the first step. I can't have the absolute value of something be a negative number, so I definitely can't have it be less than negative 7, so I could have stopped at that step and made it no solution. But the important thing is to realize as you're going through the problem that you're going to end up with a conflict. And you could see that in our picture. When I would get down to graphing it, I would be trying to say it needs to be less than 5 and at the same time greater than 9, and I'm ending up with 2 pieces when with an and statement I should end up with one piece, which once again means that there are no Now to our last two. Still need to get the absolute value bars. So my first step is going to be to minus 8 from both sides. I'm just trying to save a little room. 4 times the absolute value of 6 minus 2x is less than or equal to 16. Divide by 4. Divide by 4. Absolute value of 6 minus 2x is less than or equal to 4. So first inequality is just drop the absolute value bars. Second inequality, keep what's on the left, flip your inequality, and change your sign. Since I started with a less than, this is going to be a and compound inequality. Now I need to solve both of these. So 6 minus 2x is less than or equal to 4. And 6 minus 2x is greater than or equal to negative 4. So be careful on this one. When we have that constant first, you need to subtract first. So negative 2x is less than or equal to negative 2. Divide by negative 2. So I get x's, flip your inequality because you divided by a negative, greater than or equal to negative 1. And make sure you're minusing 6. Negative 2x is greater than or equal to negative 10. Divide by negative 2. So x is less than or equal to 5. Let's finish with graphing our solution. 1 and 5. They have equal to's, so I'm going to fill them in. So greater than 1 and less than 5. Last question. So I need to get my absolute value bars by themselves. So my first step is going to be to minus 3 from both sides. Once again, I'm just writing on top of there to save a little bit of space. Same signs add and keep, so that's going to be negative 92. Divide by 4. So absolute value of 3x plus 7 is greater than or equal to negative 2, 8, 1, 12, 23. Now, work smarter, not harder. My absolute value of anything is going to be positive, and a positive number is always going to be greater than or equal to a negative number. So what that means is that this is going to be infinitely many solutions. Or you could say all real numbers. Let me erase this. All real numbers. Now, if you don't want to write all that out, you can actually do a capital R with an extra line through it if you didn't know that for all real solutions.